Hello guys, today we're back again with another graph sketch. We need to sketch f of x, which is equal to mod x squared minus x multiplied by sine x. Well, we've got a product of two functions with our functions being mod x squared minus x and sine x. So the first thing we should do is sketch each function separately. So we've got mod x squared minus x. Well, when sketching a mod graph, you should always sketch what's within the mod. So that's x squared minus x, which has a root at 0 and 1. And, we know this part here will be modded. So we just draw that using dotted lines. Now let's draw our modded graph, which looks something like this. Yeah, cool. Now we've got to sketch sine x, so let's quickly bring that sketch in. Perfect. Now, when we've got sine x and cos x as one of our products, we know that our graph is restricted to some values. Well, let's look at the graph sine x. It's got some, we can say, critical values. So we've got a critical value here at 1, 0, minus 1. Again, 0, 1, 0, minus 1. So now let's look at a function when we've got our input as 0, minus 1, and 1. So let's look at f of 0. So when we've got f of 0, well, we've got sine x here equals, no, we shouldn't look at we shouldn't look at f0, we should look at when sine x equals 0. Sine x equals 0. Here we've got f of x equal to 0. So that means we cross the x-axis. And then when sine x equals 1, we know that f of x just equals mod x squared minus x. And now when we've got sine of x equal to minus 1, let's just drag this down. Start off with sine x equals minus 1. Sine x equals minus 1. You've got f of x equal to minus mod x squared minus x. So let's shrink this and sketch mod x squared and minus mod x squared minus x, sorry. Yeah, so we're sketching these two graphs because we know our graph will be no larger than these graphs here. So if we sketch, well, let's do, that's mod x squared minus x. And we do the minus of that, we're just reflecting in the x-axis. And we've got something like this. Let's label our roots. We've got 0, 1. Now let's assess how sine x acts when multiplying by this graph. So we start off right. Sine x from 0 onwards, sine x starts off increasing. So let's draw this in red. However, it's increasing towards 1, meaning it's a fraction. Like for example 0.1, 0.2, 0.5. So we know it will be less than this graph. And then obviously when we get to mod x squared minus x equal to 0, our graph will just be at 0. So now let's assess the behavior of our graph between 0 and 1. Well, we know we're timesing by an increasing value of sine x as we move towards 1. So we can say that, our graph leans towards 1 in a sense. Alright, fine. Now let's look at what happens when the graph moves beyond 1. So we've got our critical regions such as, we can look here, pi over 2, pi, 3 pi over 2, 2 pi, so on and so forth. So our next critical value will be pi over 2, where here, when we have sine pi over 2, we've got 1. So mod x squared minus x is being multiplied by 1. So we will be on the graph mod x squared minus x. So, here pi over 2. And then we have pi, we're going straight back down to 0. And then when we've got 3 pi over 2, so about 3 over 2 pi, well, we've got pi over 2 pi, 3 pi over 2, we're at minus 1, which is just our minus mod x squared minus x graph. Let's just continue this. Notice how our graph is essentially, our peaks of our graph just keeps increasing and increasing. Yeah. And now let's look at our negative when our input is less than 0. So we've got, the first critical point is minus pi over 2. So we've got a point here, minus pi over 2. Then we've got pi, not pi, sine minus pi, which equals 0. And then that should be more rounded. Then we've got 3 pi over 2, which is minus 3 pi over 2, which is just equal to 1 here. And then we've just got the similar shape acting. We've got a similar shape as we did past positive 1. So we've just got, again, an increasing peak every time. Sorry, this should be a bit more stretched out. Yeah, that's much better. Let's extend this. And yeah, that's it. We have successfully sketched f of x. I hope you enjoyed. Hope to see you in the next graph sketching video. Goodbye.